All right, let's do numbers 4, 5, and 7. Okay, this is again from your related rates homework. So, number 4, a spherical balloon is inflating with helium at a rate of 400 pi cubic feet per minute. Okay, so our unit helps us, right? Cubic feet is a unit of volume per minute. So this is a change in volume over change in time. So we're going to call it dV dt. How fast is the balloon's radius increasing? So there's our question mark, right? dr dt. How fast is the radius increasing at the instant when radius is 5 feet? Okay, so over here, here's our list of information. So if we wanted to have volume and radius of a sphere relate to one another, right, then we need volume of a sphere equation, which is 4/3 pi r cubed. So if we take the derivative, both sides with respect to time, what do we get, Maggie? That's exactly right. We get 4 pi r squared dr dt. Very good. Okay, so we have dV dt is 400 pi equals 4 pi times 5 squared times dr dt. Beautiful job. So Jackson, what do we need to do to get dr dt by itself? Well, that's right. We need to divide by 4 pi times 5 squared. Divide by 4 pi times 5 squared. And I will leave it to you guys to figure out the unit on dr dt. By the way, they told us it's feet per minute. And also to simplify that if it needs to be simplified. Okay? Let's look at number 5. A piston is seated at the top of a cylindrical chamber with a radius of 6 centimeters. So we're going to write down 6 centimeters. When it starts moving into the chamber at a constant speed of 2 centimeters per second. So if the piston's at the top and moving down, that's the rate of change of height, okay, of the fluid in the piston. Yes? And since height is decreasing because the piston's moving down, dH dt is negative 2 centimeters per second. What is the rate of change of volume in the cylinder? So there's our question mark, right? dV dt is our question mark. At the instant when the piston is 18 centimeters from the height of the chamber. So height is 18 centimeters. Okay, so we got volume of a cylinder, which is pi r squared h. And we're going to take the derivative of that. Okay, so Davis, what do we get? Very good. That's right, Davis. We are going to do u and v. Okay, and so we get the derivative of pi r squared, which is 2 pi r dr dt, keep the h, plus, Brennan, finish it out. What do we get? Very good. We get pi r squared dH dt. Okay, now what about dr dt? What's the change of radius for this piston? That's right, 0, because radius is constant. The radius is exactly the same anywhere inside this cylinder. So dV dt, our big old question mark that we're trying to find, okay, equals pi times r, which is 6 squared, times dH dt, which is negative 2. So notice the 18 centimeters didn't actually matter, right? And that's because the rate of change of volume is the same anywhere in the cylinder because the radius doesn't change. Unlike a cone, right? Okay, remember we did our snow cone. Very, very different than a cylinder like this. Or a cylinder like the oil spill. That one was a little different too, where radius and height did change. But here the radius is the same always, so dr dt is 0. Let's look at number 7. This one's kind of a doozy. Guys. A 5.5 foot tall woman walks 4 feet per second toward a street light that is 22 feet above the ground. So I'm going to show you my picture in just a minute. What is the rate of change of the length of her shadow when she is 11 feet from the street light? And what rate is the tip of her shadow moving? So here's my picture, okay? Here's my lady. She's 5.5 feet tall. So not me, not that tall. And there's my street light. See the yellow? It's a yellow street light. And it's a 22-foot tall street light. She is a distance x away from the street light, and her shadow is s feet long. Okay, so you can see that we have here a lovely giant right triangle. We also have an equally lovely small right triangle. So the street light and the tip of the shadow make a right triangle, and the lady and the tip of the shadow make a right triangle. They're similar right triangles. Very interesting. I also wrote down our information. She is walking toward the street light. Okay, so X is changing at a rate of negative 4 feet per second. Since she's walking toward the street light, X is decreasing. She is 11 feet from the street light, and the first question says the rate of change of the length of her shadow. I called the length of her shadow S. S for shadow. Shadow. Okay, so since our blue triangle and our green triangle are similar, okay, we're going to set these up so that we have, let's see, 5.5 over S equals 22 over X plus S. And then I'm cross multiplying, so 22S equals 5.5 times X plus S. 5.5x plus 5.5s, and then I can subtract 5.5 from each side, which gives me what? 22, 1, 2, 4, 16.5. Hope that's right. Equals 5.5x. Okay, so I've collected my like terms. I have not yet taken the derivative, so that's what I'm going to do now. Okay, so 16.5 ds dt equals 5.5 dx dt. ds dt is my question mark. Okay, so I'm hopefully going to fill in everything else. ds dt then is equal to 5.5 times dx dt over 16.5. Lovely. The next part of this question says, at what rate is the length of her shadow, where are we? Moving. And where is the tip of her shadow moving? So we're going to call this whole thing here a capital L. Okay, because we're talking about that entire length from street light to the tip of her shadow. Okay, so I'm going to set up a new, proportion. Okay, 22 over L equals 5.5 over S. And I'm going to cross multiply and then take the derivative. So 22 ds dt equals 5.5 dl dt. And so that's 22 ds dt we happen to have just found in the last part. Isn't that wonderful? And then equals 5.5 dl dt. So since dl dt is my question mark, the only thing left to do would be to divide both sides by 5.5. Okay? Very much hope that makes sense. Remember, multiple choice on Monday in class. Ask me questions if you have on the related rates, sometimes outside of class. Okay? And then on Tuesday, we will do the free response. I would plan on having a related rates free response question. I'm just saying. And this homework, this related rates homework will be due on Tuesday as well. Okay? Happy studying, guys. Bye-bye.